Record to the cloud. Okay, I think we're in business. So, we talked about this last time, that having a single person on an island has a lot of aspects of an economy, but I argue that it's not really an economy. What is it missing if you just have a single person? Exchange, right. So that other person adds something that we'll show in a little bit. However, there are a lot of elements that are true of an economy. Like what? How would one person, how many of you saw Tom Hanks' Castaway? If you haven't seen it, you should. It's just a good movie. So Tom's stranded on this island, and what are aspects of his island life that reflect things that really go on in a full-blown economy with lots of people? What does he do?
Sometimes resources are available, sometimes resources aren't.
Okay, so he's got resources available at his disposal on the island, whatever's there, right? So we talked last time about at a fixed point in time how much stuff is available for me to use. Good, so there's stuff on the island. What else? What sort of choices does he have to make?
He has to choose to go get food or go get water.
Food, water, you know, how much sun to have, whether to go in the shade. So if he goes fishing, there's a production process going on in a sense, right? I mean, that's a production process to get the final output of fish to eat. He has to go somehow catch these fish, whether he's throwing a net or does something to catch fish. And then here we've got maybe coconut harvesting. Again, he wakes up in the morning, has to go out, climb the trees, shake the trees, whatever. There's a production process. And then at the end of the day, he sits down for a meal. He's got a consumption process. Drink the coconut, eat the fish, right? So we got production and consumption going on, which is very similar to the market economy, things that go on. But he doesn't have this idea of trade with another person. He does have trade-offs himself, though. What sort of internal trades does he face on the island? Or trade-offs or trades, if you will. Even though there's not another person here, he does kind of have some internal trades. What do you think? Yeah?
He chooses to fish.
Good, right. So there's still time is an issue, and so if he goes out and spends 4 hours worth of coconut harvesting, he's not fishing. So there's really a cost to doing the coconuts in the forms of not getting fish. So that's one of the internal trade-offs, the internal choices that Tom faces. All right, so then he gets into philosophical stuff like we talked about last time about Adam Smith. I mean, imagine if you were on an island. We all saw, whoa, first example here. What's your name? Yeah, Davis. You're going to lose a point. Remember my little thing about shutting off all the gizmos? Yeah, so totally shut them off. Everybody wants to pull it out if you don't have it off. So totally disengage. You guys with laptops, did you close down emails and all instant messaging and Facebook little alert things and all that? Good? All right, there's another laptop, another laptop. All right, good. All right, so Davis. Davis is our first one to give us an example. I did talk about that, right? My first name? Okay, I just want to make sure because I was going to give Davis a get out of jail free card, but all right, what's your first name?
Davis.
Davis is your first name. I was thinking that was the last name. Last name? Goodman. All right. All right. Gotcha. Perfect. No problem. All right. So how do we do this? What do we compare it to? We get another person on. One of the things Adam Smith brought up in that theory of mutual sentiments is that it allows us to compare each other. Like, I do something bad, if I'm all by myself on the island, who's there to say it's bad or good, right? It's just what I like to do. And all of a sudden, morality starts to be kind of challenged when we start to have groups of people and we start to get these norms of values on the island. So that's a little bit about what he talked about in that first book. In the second book, The Nature and Causes of a Wealth of Nations, he challenged some of these ideas about the choices that are going on and what we can do. So this, by the way, this material, if you guys printed it off, this was some of the sheets that I asked you to print off from the MyEcon lab. The buckets and circular flows, it's one of the tabs. So if you have those, I see some people have them, you can pull them out and take notes as you go through. So this is where this stuff, and the reason I like to go through this is we're going to come back to this kind of throughout the semester. Some of the principles linger on into the big economy from our little starting place here of Tom and Jen on the island. All right, so here's the situation. We've got two hypothetical choices for Tom. He can do 8 coconuts and 8 fish in a day, let's say, or 4 coconuts and 12 fish, right? So there's kind of that internal trade-off, right? We give up some coconuts, we get more fish. So we're starting to pick up on some of that. And then we got Jen facing a similar type of choices, but for her, she could have 4 coconuts and 8 fish, or 3 coconuts and 11 fish. Look at those numbers. What are they saying about the people and their productivities? Yeah. What's your name?
Blake.
Blake.
Fish is a more valuable commodity than coconuts.
Okay, why do you say that? Or where are you getting more valuable? What do you mean?
Okay, I don't know if I said that right, but
because they're getting more of it or something,
they want more of it. I thought in terms of like sustainability.
Okay, so right now I'm glad you brought that up. We're not addressing kind of their values or their wants, but rather what they're able to produce. So on a given day, Jen can have A or B. That's just 2 production possibilities. And then same thing for Tom. These are 2 production possibilities. We're going to leave aside what they might want or value with the 2 items at this point. Jake?
Yeah. Jen is
Blake, Jake. Got it.
Jen produces fish, like, I guess better is what I'm trying to say, but because for every 1 coconut she can gather 2 fish. So.
Okay, so you're starting to do some trade-offs in your head of how much they can get of each if they give up something. Okay, good. That's the type of thing you want to look at. Other things you pick up with that. You see some of that trade-off? He's kind of looking at the changes here, and we're going to play on that a little bit more. Other things you see. We can make a bolder statement about these 2 in terms of production. There's kind of a big, bold statement that's hanging out there. What's that? All right, so Tom is more productive. Why do you say that? He has more of both, right? So on a given day, Tom can do more of both things, right? So Tom has what we call an absolute advantage in production. He's just, I guess, one of those guys that's kind of good at a lot of different things, right? So 8 and 8, 4 and 8, right? So he can get on the same day more coconuts. And then same thing here, 3 coconuts, 11, 4 and 12. So on a given day, Tom is more productive in both. He has what we call an absolute advantage in economic terms, an absolute advantage in production. All right, so let's get back to thinking about the trade-offs, the way Jake was bringing up here. So do you see how 4 coconut can be traded for 4 fish? It's not immediately obvious, but look at that trade-off here. So 1 point, if we graph this out, if we put on our graphing goggles now, 1 point is point A at 8 coconuts and 8 fish, point A. Point B is another production possibility at 4 coconuts and 12 fish. We can be at either one. So if we go back to thinking trade-offs here, I can give up 4 to get 4. And if I simplify that, it's kind of a 1-for-1, right? So if I put on my equation goggles, 4 coconuts equal 4 fish. If I want to narrow that down to 1, what does 1 coconut cost me? This side I can divide by 4. 4 divided by 4 is 1. What I do to one side of the equal sign, I got to do to the other. And now I got 1 coconut equals 1 fish. All right, so that's kind of putting our equation goggles on to solve that as well. All right, so that's Tom's situation. Let's check out Jen. Point A, point B. Give up a coconut, get 3 fish. Who's better at fishing? Jen is. Wait a second, I thought we said Tom was better at both things. What's the deal? Seems like a contradiction. And it is, in a sense. Tom's better at producing both things, but yet we're saying Jennifer's pretty good fisherman in the sense of she can give up 1 coconut and get 3 fish. More efficient?
Better luck.
Let me go over here.
More of an all-rounder, or is she more official?
She's more what?
She's more official, or he's an all-rounder.
Okay, so more of an all-rounder, more of a fisher. Let's say that they're, and you're right, they possess different skills because they're different human beings here in this case, right? And so this is being reflected in the trade-offs. So Jen has what we call a comparative advantage to Tom. If Tom gives up a coconut, he's got the 1 for 1. Jen gives up 1 coconut, she gets 3 fish. So in that sense, Jen, who can do it cheaper? Who can get fish cheaper? Right, Jen. So Jen has a comparative advantage in fish. 1 fish costs 1/3 of a coconut, if we break it down to 1. Now there's another equation goggle thing, right? We got 1 coconut equals 3 fish for Jen. So what does a fish cost her? 1 fish, because we usually put it on per unit terms, right? Divide by 3. 3 divided by 3 equals 1. What I do to one side of the equation, I got to do to the other. 1 fish equals 1/3 of a coconut for Jen. So she can do it cheaper than Tom, who it ends up costing him 1. All right, so here's kind of the layout of both of them, plotting both of what we're going to be calling their production possibility frontiers. Tom's better for coconuts, Jen's better for fishing. So what does this kind of tee up for us as far as society goes on the island? What might be a good idea to maximize happiness or welfare on the island?
Each person should
Yeah, each person should do what they're good at, right? And so since Jen can do it cheaper, why don't we have Jen do the fishing, Tom do the coconuts, and then we do some trading, right? That's kind of what we're teeing up for specialization. So what I did here is I assumed that they had this productivity trade-off all the way to the nth degree. So it's possible for Tom to spend his whole day harvesting coconuts, and he could end up having 16 for the island. So the island's production of coconuts would be 16. Jen spends her whole day fishing. She comes back at the central meeting spot, and she's got the 20 fish. All right, so let's look at the overall island production. I've restated each one of their production possibilities here, and this ends up being the world's production possibilities. Using resources as efficiently as possible, resources being these 2 human beings, by the way, is kind of all we got on this island for simplicity. And the colors here on the frontier are matching the individuals for an important reason. Suppose that we start off at this point. First of all, is this point possible for the island? With 36 fish. If they both did it, right, good. So that would be Jen spending her whole day fishing. They could have 20. And of course, we learned before, Tom spending his whole day fishing now. the 1-for-1 trade-off gives us 16. 20 plus 16 gives us 36. So boom, we're here at 36. If I all of a sudden say, you know, we got so much fish, but I'm kind of getting thirsty. Sure be nice to have a coconut. Who do I send out? Who do I free up? Which person gets that job if we're acting efficiently? Tom. We're going to send out Tom for the first coconut. Why? More? Yes, he's more efficient. Talk to me in terms of cost. It's cost effective and give me more meat on the bones, yes. So I want one coconut. The first coconut, Tom, go get us a coconut. We only lose one fish. That's what I wanted to get at, is that we only lose one fish. Had I had sent Jen out, I would have lost 3 fish, right? So what I'm starting to do now is snake along this production possibilities frontier, which of course mirrors Tom's individual one, because that's what was going on over here. We're just kind of snaking up along here. And so we go to here. Eventually, if we get to point XC, and I still want more coconuts, that's a possibility. We might be really thirsty. We might be dehydrated or something. Who do I send out now? Jen. No other choice, of course, right? And so now the slope of the production possibilities frontier for the world reflects our other resource here, the less productive, the less efficient resource, Jen, in getting further coconuts. Notice what happened by using resources together. Our straight line concepts with equal productivities within the individual turned into this bowed outward production possibilities for the world. Right? So the shape of this production possibilities frontier is now bowed outward. That'll be important later when we get into some other deeper concepts as it goes. Now I threw in XA and XB to show you something. What if each person acted independently and they did a little bit of fish and a little bit of coconuts, right? If they're at XA or XB, they are where relative to this line? Under, they're inside. So by not having specialization to the extent of Jen doing all the fishing, Tom doing all the coconuts, we are inside the production possibilities frontier, which now reflects a point of inefficiency. From the economic standpoint, it says, you know what, if you did this smarter, if you put the right people in the right spot at the right time, you could be out here, which is clearly superior to this point. Why? You got more of, which one? Both, right? So we got more of both things. So we've got everything pushing out, whether you're at XP, XA. In fact, any other combination in here of just combined production is going to be somewhere inside the frontier. All right, let me pause for a sec. Questions or comments on the setup? All right. So here we go, right? We got this guy sitting over here with the shades, cool dude, with 16 coconuts. We got Jen over here with the wink and the flash of 20 fish. Are they going to be able to strike a deal? Are they going to be able to find some ground that makes them want to trade in the first place? What if Tom says, how about 2 fish per coconut? What do you think Jen says? Yes. Why? But that's right. It's more than what she would get if she did it herself. So if she can do that trade, she's giving up 2 fish to get 1 coconut. If she did it herself, what would she have to give up? 3. So it's a deal for her, but wait a second. Would Tom ever actually offer that in the first place? Is that a deal for him? Yeah. No? Yeah? I see some heads shaking. So he's giving up 1 coconut and getting 2 fish. If he did it himself, he would give up 1 and get 1. Oh, the market is born, right? We have it. We've developed a situation where we can make both parties better off, given the same amount of resources, by doing what? Simply specializing in what they're good at, and then engaging in trade, engaging in exchange. And it's not that zero-sum thing where $1, one person gets $1, the other person loses $1, but rather through the market system of exchange, both parties are made better off. It's a win for Tom, it's a win for Jen. It's a win-win situation. We're not losing anything. We're making both parties better off. That's that engine of exchange, of voluntary exchange that can make a couple parties better off. All right, so what if Jen said, come on, 2 fish. How about 1.5? I'll fillet this baby up. I'll give you 1.5. What's Tom going to do? First of all, does 1.5 create still a win-win situation? Yes, right? Because now Tom's getting 1.5 fish. If he did it himself and said, screw you, it's going to cost him 1. So even if he doesn't really like her and she not like him, by working together in this trading thing, they can still both be made better off. So that part's going to come down to negotiations. What we can say from this is that there's a range that will make both parties better off. And so as long as Jen is not paying more than 3, right? If she's giving out 2.999, she might still say, screw it, I'm not going to play that game. But in theory, she'd be willing to give up to 3 because that's the best she can do on her own. And Tom, on the other side, needs at least 1 fish. And so between 1 and 3, both parties are made better off. So we have that kind of negotiating range, if you will, where we're going to get both parties made better off through this trading thing. Questions on that? Comments at all? Starting to... All right, so let's say she's got a deal. They do the 2 for 1. This graph here shows the consumption possibilities for each party. And this is where it's really, again, that aha moment, hopefully, of if Tom operated solo, like he did before Jen washed up on shore at the island, what he produced is what he consumed, right? What he produced is what he consumed. And so this was his production possibilities frontier, but it was also his consumption possibilities frontier. Now with trade, we're going to break those 2 concepts apart, potentially. And so at a price of 2, Tom gives up 1 coconut. He doesn't get 1, he gets, boom, 2. And we're outside of the production possibilities with a new consumption possibilities frontier. And then these 2 can keep engaging in trade, potentially getting to a point like D, where D is clearly preferred to A because Tom has more of both goods. On the flip side, Jen, remember, she did not have an absolute advantage, but she had a comparative advantage. She's got the same thing going on. So she produces all the fish, she brings them to the market, she starts snaking along here because she used to give up 1, 2, 3 to get 1 fish. Now she gives up 1, 2, boom, gets 1. All of a sudden we're trucking along outside her individual production possibilities frontier. And so the slope of the consumption possibilities frontier for each of them, if we do a little rise over run trick, we get down 1 over 1, 2. It ends up being a half, right? Rise over run, down 1 over 2. Rise over run 1/2, negative 1/2 technically. Same thing over here. We have this being a slope of 2, where we've got up 1, down 2, rise over run 1/2. So that ends up being the term, what we call the terms of trade, the deal that they struck. It would be the market price of fish and coconuts. All right, so questions there? Well, how does this stuff work? How does this stuff scale up? If you're, how many people have watched Shark Tank? Any Shark Tank watchers, right? So when you're sitting in front of the sharks and you're running some business, they're not looking to make just a few $1,000s. They want to make potentially a few $1 million, right? And so one of the questions that they grill them on all the time is, how does your business scale up? How does this thing work to make some additional money? And I think that's what we see here with Adam Smith's idea. This is the idea of specialization. Specialization is Tom doing what he has a comparative advantage in coconuts, Jen doing what she has a comparative advantage in fish, and then engaging in trade. How that scales up with 300 million people on our island is that these people who live over here, the Toms and Jens of the world, with even some kids and different people, they, for part of a day, go to a place of business, which is a collection of people who are looking to do some specialization in a particular activity that each one of them are pretty well suited for. And so as a group, they make a firm and they sell stuff, whether it's goods or services, right? So that's in a nutshell how we see Adam Smith's Wealth of Nations idea manifests itself on a large scale, the idea of businesses. At the end of the day, happiness for society resides over here, right? And so some people work, some people don't work. So I've got this diagram here reflecting loosely the United States economy, where our labor force is about half of the population. So we have about 300 million people, actually a little higher. Anybody been taking a population class or something, you know, where we sit population-wise? Yeah, I think it's like up to 320. That sounds about good. And so about half of them are in what we call the labor force. Who from macro class, let me put a little quiz out to you, who remembers what the labor force means? Those who are able to work. No, but thank you. Extra credit point for getting the wrong answer. Who else?
Willing.
Willing and able to work. Good. So you need to have that willingness part, right? So to be in the labor force, another way to think about it, it's the people working, because we've abolished slave trading and slave work. If you're working, you're doing it voluntarily. It may not feel like it some days, but you're volunteering to work, which means you want to work, which means you're in the labor force by economist definition. And then the other people are the ones who aren't working, the unemployed. But what's the key thing, macro people, that you need to be if you are not working? What do you have to be if you're unemployed? If you're technically unemployed, you have to be willing and seeking and wanting, right? It's like, I'm looking for a job, I just can't find one. Then you're unemployed. But there's lots of people who are able to work but choose not to. Like who? Retired people. We could get down to children, maybe age 12. They're fully functional to be able to do some work, but you know, some child labor laws get in the way for them getting out there. Except if you live on a farm, then you're out busting your tail with dad, baling hay and stuff. But other than that, we got that sort of thing going. Okay, so that is our Tom and Jen stuff on the island. Now we're going to dig a little deeper into our opportunity costs and production possibilities. So, let's see here. There we go. Tried and true. So here's a definition for you of the production possibilities frontier. The production possibilities frontier. And here's my suggestion for you, if you're kind of new to the class. Whatever I write on the board, you write on the board. It's kind of this monkey see, monkey do. And that'll give you hopefully a good set of notes for you to refer back to when you come to homework problems or other things. So, production possibilities frontier. This thing shows the maximum combination. The maximum combination shows the maximum combination of two goods an economy can produce given its available resources and technology. Shows the maximum combination of two goods that an economy can produce given its available resources and technology. Okay, so let's just jump into an example here. Suppose the economy produces two goods. Beer and pizza. Beer and pizza. That's all we got. So I'm going to have you put your schedule goggles on, and we're going to look at the different combinations of beer and pizza, the quantities that can be produced. If the economy cranks out 20 beers, it can't have any pizza. So 20 and 0 is one combination. Now, if it gives up some beer, it can have a pizza. So 19 and 1 is another combination. 16 and 2 is another combination. 12 and 3 is another combination. 7 and 4 is another combination. And finally, if it has 5 pizzas, it can't have any beer. Sad day. So I'd like you to graph this out. So draw a graph, give yourself plenty of room. With this particular graph, we're going to get sloppy later, but I'd like you to be pretty specific on the scaling of your graph. So this is the origin, 0. We're measuring pizza on the horizontal axis, beer on the vertical. And then kind of evenly space out. Of course, it doesn't have to be perfect. You don't have to get a ruler out or anything, but 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then over here, we're going to go up 20. And it's not going to be the same scale, but you can just kind of eyeball them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. I ended up making that a little smaller than I was hoping. Now that you guys got the gist of it, maybe I'll even make it bigger. What the heck? And then start plotting the points. So if you got some questions, I'll come around the room, see how you're doing.
populate a little graph there? Or? I don't see your notes open. I don't want you on the home. Oh, they are? No, I'm sorry. Now you do that little graphing deal. We're going to do this a lot. And you might also just keep a notebook paper, just as a side problem. I have had students do it. It's usually a little tougher. So, did you got a graphing thing? How to make graphs? Okay. So, make sure it's set up to do graphs. Otherwise, make a piece of paper next to you. It's not that.
I said that's perfect.
Right, so I see some dots on the paper, good. If you drew it real carefully, with equal spaces between the two, like I attempted to do up here, what do you see about the shape of the dots? It's curved, it's got that bowed outward look, right? So we've had 20 and 0, 19 and 1. I'm going to add a little bit of dashed lines to help me out here since I got this dot, dot, dot. Dot, 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 and dot, 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 and then 5. So if you want, you can go ahead and kind of make a curve go through there. And that is your first production possibilities frontier. Now, there's kind of some weird things going on with the numbers, right? I mean, why is it bowed out? I mean, what's going on here are these, if we think about these trade-offs like we did with Tom and Jen, you know, what is the cost of the first beer? What is the cost of the first beer? So we might even write out the opportunity cost of the first beer is, what would you call the cost of the first beer? 1 pizza, right. So we got 1 pizza, or the first beer. Where'd you get your 1? Say that again?
Unless you can have half the pizza.
Okay, I'll allow some fractions.
Okay, so a quarter of a pizza.
A quarter of a pizza? I like the math, if you're saying without doing the math. Okay, well, I heard another answer. Did you come up with something different? You know what? Let's go to the first pizza. Would that be easier? How about the first pizza is 1 beer. All right, so now let's check out what's going on here. We go from 0 to 1. I give up. So the first pizza is 1 beer. What's the opportunity cost of the second pizza? The opportunity cost of the second pizza is 3. Wait a second, I thought we went to 4. How many people are thinking 4? People thinking 4? So it's a little bit of a trick question until you start to get it. What is the 3 is the right answer, but why? What's the key thing that you got to hang on with the way I wrote that sentence? If I can call it a sentence. The second, good. What's that, a little louder?
That's the second you already have.
I already had the first. That's right. So you got to kind of hang on the and the urds and the all that, because we're really looking at the incremental unit, right? If we're looking for the cost of the second one, then implicitly I already have the first one. I'm looking for the second one. And so on this trade-off here, the first one I go from 0 to 1 is a 1 to 1 trade-off. The second one, I get 1 and I give up 3. Got it. So the second pizza cost me 3 beers. Now I could get, you won't see this in the homework, but just hopefully this will not be more confusing and just make sense. If I worded it, what's the opportunity cost of the first 2 beers? That's being a little slippery, right? But now I'd be saying to go from this point to this point, the first 2 beers cost me 4. Then that language would be right. So it's important that we're breaking it down to the...
You mean the first 2 pizzas?
I'm sorry, yeah, I said that backwards. Correct. The first 2 pizzas, yes. This is already confusing enough. So yes, thank you for bringing that up. Okay. So let's keep going just to make sure we got this. So the third pizza. 4. Good. So I get 1 more, specifically the third, at the expense of 4 beers. And now we can go ahead and just fill this in, right? I got 1. Hopefully you're starting to get the feel of it. I get the 5th, and it's 7. So this is a good thing to do on a homework problem or on scratch paper if you're working online or whatever. So the third pizza, we had the 4. The opportunity cost of the fourth pizza is our 5. And then finally that 5th pizza, whew, that was an expensive one. We must have been wanting it real bad. I gave up 7 beers. So the cost of each additional pizza is going up. But each time you run to Pizza Time for the dentist special, which is awesome, by the way, talk probably more about that later, it runs, I don't know what it runs exactly, $16.99, let's say. Every time I go, the cost is $16.99, $16.99, $16.99, $16.99. Whether I get the first one, the second one, the third one, as long as they're not running some special that says the 5th one is cheaper than the first. So what's going on here with pizza becoming more expensive? I mean, does this have more ingredients? Fancier cheese? This is like the plain cheese, and this is the supreme extra thick crust with loaded cheese stuff. Am I making anybody hungry here? Kind of lunchtime. I better be careful. Higher demand. We're not bringing any demand elements into it. So I'm glad you brought that up. Similar to when I ignored Blake's comment on value. Right now, we're just going to focus in on the production possibilities. And what we're observing is we're seeing the costs go up.
Once you start making more pizzas, you have to devote more of your resources to the pizza, and this takes away from the resources for beer.
Okay, so there's this trade-off of resources, right? So we need resources for pizza and beer. And you're right, there is something going on here. As I start to shift this way along the frontier, I'm taking away more and more resources from the production of beer. And when we get to this point, we're just slamming them into pizza production. Almost idiotic type of production. So like you got that, you know, the big, how many of you have been to a brew pub? All right, you got those big vats that the brew is in there. Well, now we're just using those for tomato sauce for the stupid pizzas, right? So as a society, we got these huge things that are really designed for beer production are going into that. And then worse yet, we've got like barley and hop crust because we don't know what else to do with the barley. Oh, maybe we can make a crust out of it, right? So here we are slamming every single resource in the economy into pizza production. However, some resources are better suited to beer production. Some resources are better suited for the production of one good or the other. And so by us focusing more and more resources into one particular place, you're having to give up a lot more beer because we can use that vat. Now the flip side is kind of easier to think about. If I take that thing that we were having tomato sauce in, is it relatively cheap or expensive to get my first, second, third, fourth, fifth beer? If I free up, it's pretty cheap, right? It's like, oh, finally, I got that guy that's the brewmaster that I've had to be the tomato paste master. finally he can start making brew. This guy's really productive at making beer, right? So all of a sudden I'm going to free him up and I say, okay, let's go get some beer. Because I'm freeing up resources that are better suited towards beer production that were being slammed into pizza production, as I free them up, it's like, woo, we get a lot of beer out of that, right? It didn't cost us very much. It was pretty cheap. And so we've got that element going on in the economy here at these endpoints. And that's what gives it this bowed outward look, because some resources are better suited for the production of one good or the other. All right, comments or questions on that? I'm going to write that on the board, but as I erase, questions? So here's a good test question. Why is the production possibilities frontier bowed outward? And the answer, there's kind of a couple different ways to word this, and I'm going to give you both of them. They work in harmony with each other. But most generally, some resources are better suited. Some resources are better suited for the production of one good or the other.
Will there ever be a case where it bows inwards?
Inward. No. I can't think of one. There'd have to be some weird technology. So the answer is no. But we can get to a point, or theoretically anyway, I don't think this holds much theoretical water, where it's like Tom and Jen, where it was straight line. And what the straight line means, since we brought up the bowed out thing, the straight line for the individual, like in the Tom-Jen situation, just meant, hey, I give up an hour, I can get this ratio, and that ratio is fixed. So an hour's worth of time, to put it in this lingo, for Tom or Jen, an hour's worth of time was equally well suited for the production of coconuts or fish, right? That unit of time that we were putting that resource, an hour of labor, I should say, is equally well suited for the production of coconuts or fish. That would give you the straight line. Yeah.
Would it cause an inward bow if you included the amount of time it took to travel from where the coconuts are to where the fish are?
No, because we're holding time constant actually. So when we gave the example, we said a day. So whether it's a minute, an hour, or whatever, time is actually kind of held fixed. And we're looking at the production possibilities over that unit of time. So the answer is no, that time doesn't factor in. All right, so what's happening to the cost? Is it going up or down as we acquire more and more of the good? Cost is going up or down with these numbers, do you think? It's going up, right? So there's increasing cost. That is called the law of increasing cost. So why is the production possibilities frontier bowed outward? Another way to phrase what's going on here, so I'm going to put it as a second bullet, is the law of increasing cost. And that is, as you produce more and more of a good, the cost of each additional unit eventually increases. Time to get back to the tough one. The opportunity cost of the first beer is, are you ready?
No.
Okay. Just wanted to give you first shot at this.
No.
The opportunity cost, this is worth an extra credit point. So, and you don't lose anything for being wrong, so that's why I appreciate. Opportunity cost of the first beer is a 7. Oh, I want to give it to you so bad, but you're not quite right. You're really, 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 really close. I'm going to give you a chance to pause. So, the opportunity cost of the first beer is 1/7. That's wrong, but how can you make it right? What did you say that? Did you say that, or did somebody else? Yes, that's right, a pizza. It's totally wrong if you don't have the label on there. So it's a 1/7 of a pizza. So you got to have a 1/7 of what? A 1/7 of a dollar, a 1/7 of a penny, a 1/7 of a coconut, a 1/7 of a fish. You know, it's just not a 7. We're telling a real story here, right? So the cost of the first beer is a 1/7 of a pizza. Okay, now the fun part. Come on up. What's your name? Jared, come on up. You're getting an extra credit point for this regardless, so you've already earned that. So now we gotta have you explain where the heck the 7th came from. Show me either graphically or with an equation, you know. How did you calculate a 7? There is a number of ways to get the answer, and it is correct, okay? So show me the 7th. Nope, that looks not like a 7th to me.
Well,
I'm pushing it to you. I know, you're doing good.
the first pizza.
A little massage here, relax, you all right? So I liked what you did there, but you got to keep going, keep going. 7th pizza. Where does the 7th live? Remember the whole equation goggle and graphing goggle, and there you can look at math different ways. Well, now that's what we're doing here because we got the 7th. So where is the 7th? Okay, flipping on some equation goggles. Good. All right, now if you were really showing your work the way I did, how did you jump from here to here? All right, so good. All right, you can take a seat. I'm going to take the heat off you now. Thank you. That's good. So over this, let's walk. You verbalize this for me. I want you to verbalize what's going on with this part right here and kind of why you did it. This part, the 7 beers equals 1 pizza.
Well, 7 beers is 1 pizza, so in order to get 1 beer, you have to divide it by 7.
Okay, so if we look over here, the first beer lies in this interval, right? 0, 1, 2, 3. I didn't write them all out, but it lives in here in this little interval, so to speak, right? Over that particular area, we know that 7 beers can be traded for 1 pizza. I'm not looking for the cost of the first 7 beers. That's that kind of play on words. I'm asking for the first beer. And so our best approximation is to take that equation, divide by 7, and you get your 1 beer equals a 7th of a pizza. What do you think? Who's up for where, I'm sorry, was it Jared or Jacob? Jared. Where Jared fell down a little bit here is on showing me, and maybe he's got it now, but I'm not going to let you come back up. You already got your, what's your last name, Jared? Demon, yeah. Who can show me, for an extra credit point, where the 7th lives graphically? Show me the 7th on the graph. And I'll give you a hint. Jared kind of gave you a little bit of a hint. All right, come on up. You saw a hand. You're ancient. Come on. Let's go. Woo! It's getting good.
Yeah, I gotta get that.
All right. So where is that 7th? The mystical 7th. That one. Yeah, there you go. No! Sit down. I'm going to give you a point anyway, just for playing our game today. That's your consolation prize. What's your name?
Still Davis.
Davis lost a point, and then now it's back to even. Who's up next for our little game? Sam, come on up. Saw your hand first. What's your name? Daniel.
Seventh pizza.
Yep, I just want to say the opportunity cost of the first beer is the 7th pizza. I just want to be able to reconcile the math and stuff with the 7th.
Somewhere down there.
Somewhere down there, no. Thank you, though. Come on up. What's your name?
Colin.
Colin. Come on up, Colin.
Be right here.
No. Thank you for playing. Come on up.
Would be outside of the 5, right? Is it rise of 1?
Just put it up there, and I'll give you the yay or the nay. That is a nay. Ready? Come on up. What's your name again?
Tony.
Tony. What's your name? Austin.
Up there.
Oh, okay. Now a little more detail. You're right on top of it. So it's not the shaded area the way you've got it, but you're really, really dangerously close. So I'm about ready. I think. So show me the 7th. So the first beer costs me.
Just this little bit up to the 5.
Yeah, up to the 5, right?
Yeah.
So if we did it graphically like you're doing, you come to the curve and then drop down. That little horizontal distance is
The 7th.
the 7th. That's it. That's where it lives, right there. So this number is what? What's this number? 4 and 6/7. Good. So it's 4 and 6/7. So to get the first beer, I had to give up a 7th of a pizza. All right, so this stuff works. You don't have to necessarily know that perfect example. So let's do another one. What's the opportunity cost? What's the opportunity cost of the 8th beer? Opportunity cost of the 8th beer. I'm going to change it up on you. Do a little wild card thing here. What's the opportunity cost of the 8th beer? What do you got? So I'm looking for the cost of the 8th. You're dabbling on the right thing. 1/5 of a pizza, right. So over that range, if I'm looking for the 8th, where does the 8th live? The 8th the 8th beer lives in this interval now. Over this interval, I know that I can trade 5 for 1. 5 what? 5 beer equals 1 pizza. I don't want the opportunity cost of the 5 beers, but rather the 8th, specifically 1. To get a 1 here, I divide by 5. So if you guys don't have this on your notes, you're going to want to do it, because this is the way the homework problems and some of the test problems will be too. This is the easiest way, I think, if you remember to go through this process. I find lots of smart students, too, that try to do it in their head and they end up kind of screwing it up. So it's a good way to double check. What I do to one side, I do to the other side. 1 beer costs me 1/5 of a pizza. All right. How about the opportunity cost of the 12th? Another challenge question for you. The opportunity cost of the 12th. Quarter? No. 1/5? Wasn't that what the other one was? 1/5? Is that possible? 1/4? 1/4?
1 beer or 1 pizza?
1 full pizza? Boy, we got answers kind of all over the place. Let's tell the story to ourselves. I promise you it works. It works every time if you guys tell yourself this story. I'm looking for the cost of the what beer? Which means I have how many? Okay. So I'm moving from 11 to 12. What interval am I in? I'm still in this one, right? And so it is true, the math is going to work out the same. Going from 11 to 12, I'm still in this interval, and so I get the same answer. So it is 1/5 of a pizza. those endpoints can kind of be weird. That's where you got to tell the story of the 12th, or if it's the 13th or whatever. All right, so now opportunity cost of the, I guess we'll just do the 15th. Hopefully people are starting to become comfortable here. Opportunity cost of the 15th beer is a fourth. Good. So we got the 4-to-1 trade-off. We do the trade-off. We get a quarter. The opportunity cost of the, let's do the 19th. That one could be a tricky one too. 1/3, we're still in this interval, so I'm not able to trick you anymore. That's good. I heard a lot of thirds. And then finally, that opportunity cost of the 20th. Now we got our 1 pizza. Now we're back to our 1-to-1 trade-off. We reached the 20th. That means we had 19. We're clearly in here. All right, so are the costs of additional beers going up or down? Are the cost of additional beers going up or down? Up, down, I hear a mix. Up, how many people say up? Show of hands. How many people say down? Show of hands. The ups have it, and this time the democracy works with the right answer, yes. So it's going up. Don't let these fractions screw you up, man. I used to pull out my calculator if I'm freaking out on a test, and I take 1 divided by 5, and get the decimals. So if you start looking at the decimals, 1 divided by 5 is 0.2. We know a quarter is a quarter, 0.25, right? So 0.2, 0.25, a third is 0.33, and then finally to 1. So those numbers are getting indeed bigger following the law of increasing costs. So that's all marrying up pretty nicely there. Okay. So a couple other little dandy tricks. What is the slope of the production possibilities frontier between points, let's just now call this A and B for fun. What's the slope of the production possibilities frontier between A and B? Points A and B. What is the slope? -7, right? See some head shaking? So what is the slope of the production possibilities frontier? By the way, good reminder, I know once we start talking slope, there was a couple little butt-punching moments there that I saw a couple people raising their chairs. So get on the MindCon Lab, take the math quiz, hit the math early. You got to score 70% on it. It's due Friday. It's the first thing I have due for you. So get in there and get that done, and you'll feel a lot better about what some of the stuff we've done. If this is a little out there for you, we need to get it in there for you real quick. And so that math appendix stuff will help you out there. Did I see a hand up? Yeah. Tony, right? Yeah. Okay. -1/7 for the slope? Okay. So I heard a 7 and I heard a 1/7. Which one is it? How many people say 7? Show of hands. -7. How many people say -1/7? Show of hands. Looks like the 7 has it, and this time that is correct. So what is the slope of the PPF between A and B? Well, between A and B, the slope equals the rise over the run of a line between A and B. And so if we connect these 2 points with a straight line, which, by the way, by definition, the curve that you drew is probably outside of that, right? But a straight line, we're down 7 over 1, rise over run. So we are down 7 over 1 equals -7. All right. What is the slope of the, let's see. I don't know if I want to do another slope. I should have brought my golf club. Dang it, I haven't even had my golf clubs out yet this time. Who remembers how to find the slope of a curve? A little trickier, the slope of a curve. Yeah.
2 points, 20 and 5.
20 and 5. What do you mean?
The maximum on the y and the maximum.
Oh, the maximum and kind of figure out the overall?
Yeah.
So that would be finding kind of what I did for A and B.
Yeah.
That would be this line here.
Yeah.
And no, that's not right. For the slope of a curve, to find the slope of a curve. Let me go way back. Derivatives if you're in calculus, okay? But we're not doing calculus-based approach, so there I saw a whole bunch of butt clenches. So no, we don't need to know how to do a derivative, but that is a way you can do it. So talk to me in non-calculus language. Yeah.
All right, I don't know, but I kind of know. I think that the curve's like a parabola, right? So it'd be like x squared plus x plus.
No, you're getting too fancy.
Draw a tangent line.
Draw a tangent line. Good. So this is where I need my golf club. But so imagine this chair is a straight line here. So you see the edge of this thing? Maybe I can do this right here. All right. So to find the slope of a curve, you pick a point like point A, and you bring a tangent line right to that point until it's just kissing the line right at that point. And then you do a little rise over run with that line. And that is the slope of the curve at point A. So the key here with this is that the tangent line will change depending on which point we're at. So if we took it at B, but B is a corner point, so we can do B, but let me put another point C up here. What's happened to the slope if I evaluate it at C? Is it flatter or steeper? Flatter. So is the slope less or more? Less. It's a negative, less an absolute value. It gets kind of funny with the negative sign there. But so we got this going on where this tangent line is getting flatter and flatter. And so that is actually reflecting this idea of the cost here too. So the opportunity cost of the item is reflected in the slope of the production possibilities frontier. So if we only had our schedule goggles, kind of the way to think about this particular problem is connecting these dots like this. And if you did that, the slope between, don't ask me why I have A, B, C, D. This is probably the weirdest thing I've ever done almost on this stuff. But so between A and D, what's the slope of the line? 5, right? Down 5 over 1. So D, so this has got a slope of 5 here. It's got a slope of 7. So it was -7. It was a slope of -5 here. And if you look carefully over back at our numbers, 7, 5, 4, 3. So the opportunity cost is related to the slope of the production possibilities frontier. And that's the connection. In general, one thing that will kind of help you out on some homework and test questions is this little statement here. In general, the opportunity cost of whatever is being measured, the opportunity cost of whatever is being measured on the horizontal axis is equal to the slope of the production possibilities frontier. the opportunity cost of whatever you're measuring on the horizontal axis is equal to the slope of the production possibilities frontier. Check it out. What are we measuring on the horizontal axis over here? Pizza. The opportunity cost of pizza is these numbers. These numbers are the slope in between those points. So that's a nice little connection when you see a problem and they're asking about opportunity cost. Remember that that is embodied in the slope of the production possibilities frontier. Just what's the opportunity cost of the vertical axis variable relative to the slope? The reciprocal or the inverse, right? 1/7, 1/7, 1/5, 1/4, right? So it's just flipped over for the vertical axis variable. So there's a connection there that's important for opportunity cost. All right, questions or comments there? What can you tell me about point, what did I do, D there? What about, hey, who is my guy here again? I was going to say, yeah, Austin, Colin. Okay, Colin. Yeah, no, that's cool. That's all right. I'm not trying to pick on you. I just want to, you had a point here. So what can you tell me about point E? What's going on, the story, and from an economic standpoint, there's something important that the math, i.e. the graph, is telling us about point E. What's true? What's going on with the economy? What's the story with point E? Say that again. 1 pizza equals 7 beers. It's a production point. It's not that they equal, but point E is saying the economy is currently producing 1 pizza and 7 beers. I agree with you there, but there's more to the story. So that's the, let's say that's the point. Let me go over here. Yeah. What's your name?
Daniel.
Daniel. Okay. So this production point is possible, but sucky is the economist term that we use for that. It's possible, but sucky, or inefficient is actually the more technical term that most economists use. The sucky thing is something I've been trying to pass by in the academic journals, but it hasn't gone over so well. So point E is inefficient because why? What makes the point inefficient in a sense? How do we know it's inefficient? Let me go way back to Ike back there. Okay, so I'm with you there. I just want to hear more. Somebody other than Ike, but you're right. Now you've nailed it. The ones on the curve reflect the most efficient points. So what else can you tell me about E, about why it's sucky or what's going on? Other things to add? Yeah. Okay, good. That is one of the ideas of efficiency, is that I can have something for nothing. Now, economists are the ones that, if you've heard this cliche, there's no such thing as a free lunch. This is as close to a free lunch as you get right here, because we have a fixed amount of resources on the island, so to speak. We're currently producing at point E, but it's possible to be at a point like A, where you have more pizza, and how much beer have you sacrificed to get it? 0. It's free, right? In the sense of inefficiencies cause opportunities for you to do better for free, in a sense. I don't have to give up anything, and that's why it's inefficient. Likewise, both D and A are equally efficient with each other. That's where it gets kind of weird. It's like we can have multiple points of efficiency. So to take that definition and twist it a little bit, what does it take for a point to be considered efficient? How do you know it's efficient? If I didn't have, one kind of way to think about this is, suppose I gave you point D, and here's what I gave you. Is that point efficient? In other words, I'm not going to give you the little crutch here of this little thing, this little bowed out thing. How would you know if point D is efficient? Okay, it kind of touches on the ratios, but you wouldn't necessarily have to know them. You would to calculate them, so you're not. Nope, it has nothing to do with the placement or the centering of it. How would we know if D is efficient if you didn't have this to kind of use as a crutch, so to speak?
Yeah.
We can think about another point. So let's think about another point. I would know for sure that D is efficient if I tried to get to another point. Give me another point. Give me something. What direction? How am I moving here? Do I want more pizza or more beer?
Beer.
Beer. Okay. So I'm going to be moving somewhere, somewhere up this direction, right? How will I know if D was efficient?
It moves up into the left.
Up and to the left, right? Because by moving up and to the left, what did you have to do to get more beer? You had to give up pizza. That's right. So that's our idea of efficiency. Is if the only way you can get more of one good, specifically beer, the only way you can get more beer is you have to give up some pizza, then you're not at a point like E, which means you are on the edge of the frontier, right? So that's the idea of being efficient. All right, so let me write that out here. So our definition of this is actually production or productive efficiency, which we'll kind of refer to as PE, production efficiency. You are being productively efficient if, in order to produce more of one good, you must, underline, you must give up some of the other good. And then if you want, we'll just put in parentheses here. That means you're not inside the PPF. Not inside, and let me put comma, you are on the edge. Living on the edge. Little Aerosmith song, right? Living on the edge. If you're living on the edge, you are gaining, you have gained some efficiency because you can't do better without giving up something. Okay, good question. That's where I was going to go next. So, give me your name again. Sam, that's right. All right, Sam. I met Sam last night from Australia, got it, but I couldn't quite put it all together there. Sorry, Sam. So, A, B, C, D, E, and F. Can we get there? Do I see a hand up or are you stretching? Okay. So can we be outside the production possibilities frontier? What's that? If there's an increase in technology, then are we really outside the frontier? It moved, right. So the answer is no, we can't. So we have exhausted all of the engineering, all of the information, all of the details, and this is it, baby. This is the absolute maximum theoretical production points that are even possible. Go back to your definition, given, this is your part. Go back to the definition of the production possibilities frontier, what we started off with. I already erased it. Jennifer, what? Available resources and technology, those two things. So, given our available resources and technology, this is the best we can do. We can get to point F if there's a change in technology or if there's a change in resources. And that is economic growth. as we changed resources and technology, this thing shifts outward, possibly to a point like F. All right, so that is economic growth. So outside, points outside the production possibilities frontier are just not possible, given available resources and technology. So note, points outside the PPF are not possible. They are impossible, given, now we just tie that right back to our original definition, which was the assumption we made in the first place. Given available resources and technology. Which tees us up beautifully into PPF shifters. How do we get that sucker to relocate itself outward, potentially getting to point F? Number one, there's an increase. I just have shifters. It could shift inward too, although that's kind of unlikely. But a change in, which I'm going to start using pretty much from now on, a change in resources. So I'm going to use a little math notation for shorthand. Change is a little triangle, delta, change in resources. So for example, what are our basic resources in the economy? Land, labor, capital, entrepreneurship. So we got those 4 buckets. If we can fill up those buckets a little bit, if there's an increase in labor, that'll lead to an increase in the production possibilities frontier, a shift out or outward. If there's an increase in machines and buildings, that will lead to an increase in the production possibilities frontier. And then we've got a change in technology. Now here we really have an increase in technology, but what the heck is technology? We kind of all talk about it all the time. Oh, you know, well, with technological change and whatnot. What the heck is technology? Yeah?
I would say like anything that better helps you to do a job.
Okay, now what is that thing? Because a computer helps me do my job better, and we call that capital. So what is technology as opposed to the computer? What is technology?
Is that something used in production?
Okay, well, the computer's used in production, you're right. I mean, so what part of production? Kind of keep drilling down on that.
Having to do with like how there's a price on a computer, which makes it capital, but the resource you get out of the computer is
no, it's not that. It's not like that's what comes out of the computer. But good thinking, but no, that's not where we want to go with that. It's how you use it in a sense, yes. That's part of it. So what is technology? You guys are dancing on some good stuff. Research and information. I kind of like that. If we step back and say, what is the computer? What was a technological advance in the computer? What happened to that computer when it advanced due to technology? Research, development, a new invention, a smaller chip, a new way of processing, right? So it's really information. Now, is all information technology? No. What kind of information wouldn't be technology? What did you eat for lunch yesterday? What LeBron James did last week now that he's on vacation? That is information, but it's not technology. So to be technology, what's the key ingredient to turn information into now technology? It has to be useful for Production, yeah, for production of something, right? So now it's part of our production process. We've got labor, we've got capital, we've got machines, we've got people. We put them together with technology, or sometimes they're made better with technology. That's the information used in production. So when we have a change in technology, that increase, if you will, in technology leads to a increase in the production possibilities frontier, a shift outward. So let's go back to our beer and pizza, but you can see I want you to start with a new graph. We'll just make it a little sloppier this time. We'll have quite all the details. So, example, suppose a new invention of a dough machine, pizza dough, if you want me to be real specific here, a pizza dough machine increases, or let's say doubles production or productivity, doubles productivity. Will this give us more beer? Throw a curveball at you. No. I was just repeating what they said. I'm going to tell you no. The answer is no. So yes, no. What's going to go on? Let's try to think. So let's first of all start off with kind of a basic graph to work from here. And let's go ahead and put beer up on the vertical axis, pizza on the horizontal, and then just draw any old production possibilities frontier. We're just going to get a little sloppy and just do a curved one like that. All right, so given this invention, how would you reflect that with a doubling of productivity? So a doubling of productivity.
It basically like same starting point from the beer, but go further or twice as far.
Okay, so these endpoints are kind of special in that we can kind of think, if I slam all the economy's resources into beer production, is what this endpoint is saying, right? Does this pizza dough invention help us out at all if we devote everything to beer? No, right? So down here, we can do this many, and will it help out with pizza production? Yes. So are y'all with me that that might look something like this, maybe? If we just kind of eyeball it. So we've got this kind of shift. So this would be the PPF1, let's call it, and this is the PPF2. Back to the question, will this give us more beer?
No. Yeah.
I still hear some no's, some yeses.
Give us cheap can, make each of our beers we have more time to make it.
So maybe, yeah, I mean, you're getting the right time. We're not really bringing time into it. So those people who say no, your answer's correct on one unusual circumstance, but okay. We could still put in some effort, though.
They're independent, so regardless of how much pizza you make, it will make much more beer.
So you're on the no side. Okay. Way back.
If you don't make any pizzas, you won't get more beer, but like if you make 5 pizzas, you're gonna have more beer.
Now, 5, are you putting me here or somewhere in the middle?
So like if without the invention, if you make 5 pizzas, you're not gonna have any beer, but with it, you're gonna.
So you're putting me down here?
Yeah.
So if I'm starting at this point, if I was down here, it would help me. If I was up here, it wouldn't?
Yeah.
Is that what you're saying? So will it ever help me?
Well, compared to the chart you just had, you can have more beer with the same amount of pizzas. Like what you're saying, if you had 5, which is what you guys I can make,
So help me out with the graph here. With this,
Go up.
where am I starting?
Go up to the line.
So go like here?
No, to the new line that we have right now.
Here?
Yeah.
Okay. I wanted to start here, but I'll roll with you.
You could previously make.
Okay. So yeah, I think you're telling the right thing, but I want to start here and then see what the invention does for me. So are you okay if I start here? So starting here is where we live today. Boom, new invention. Now where could I possibly be? There. Could I be here? Could I be here? Could I be here? I can be anywhere. And as long as I'm on the production possibilities frontier, I am what type of efficient? I think I heard it. What? Production efficiency. Good. Anywhere along the production possibilities frontier is productively efficient. And so since I have this dot here, I could move to a point like B. Right? So the pizza dough machine helped me get more pizza. That was intuitive. Do I have more beer too? Do I have more beer too at point B? Yes. What the heck is going on here? Why do we got that? Now I think Ike was touching on the reason there a little bit. Go ahead. The opportunity cost is cheaper. It's different. Things have changed, right? One way to think about this is if this pizza dough machine is all awesome, what might it do to my labor in the pizza making process? Decreases it. Do some people get unemployed?
Yeah.
Do they stay unemployed forever?
No.
Where do you think they go to work?
Here.
Got it. So the economy is going to start reallocating resources due to the invention because of the cost differential in different places to possibly get to point B, where we have now, notice, anywhere along here, we have more pizza and more beer. That's pretty awesome because anytime we have changes in technology or increases in the resource base, not only does the cool gadget help our lives out, but it also frees up resources for us to have more of everything. That's a pretty powerful thing going on there in terms of the market system, where a technology in one particular sector can lead to prosperity or more stuff in all sectors. Pretty awesome. See you on Friday.
In regards to the homework